All right, let's take a look at some proofs. Let's take a look at some steps and some things that we can remember if we're trying to do a proof. So I've got 6 statements here that I think might be helpful to keep in mind when you're trying to do a proof. First of all, we've talked about this before. Always remember that the first statement is probably going to be the given information. It's not always going to be the given information, but most of the time that's a good place to start. The last statement you're going to make is going to be whatever it is you're trying to prove, what I call the prove statement, right? That's what you're working towards. That's going to be your last statement. Anytime you have multiple statements that are going to use the same reason, you can combine those statements into one. So if you were going to use, let's say, the angle addition postulate to say that, to make a couple statements, you can combine those statements into one and then just write angle addition postulate one time rather than writing it multiple times. A lot of times our statements are relying on previous statements, right? We've seen this before where, especially in substitution type situations, you have to say that two things are equal before you can substitute one for the other, so that a lot of times you are kind of building towards a certain statement that you're going to make. If you have a hard time getting started, which is where proofs usually are complicated for most people, is where you're going to get started. A couple tips for you. First of all, just try something. Try a few different approaches to see where they take you. Oftentimes you'll find that if you just look at the given information and say, okay, if this given information is true, then what else would definitely be true? And then you can just start kind of going down a certain path and see where that takes you. So that's something to try. Just try something, and if it works out, great. If it doesn't work out, you just try it. You just start over. You try again. A lot of times you want to reason backwards from whatever it is you're trying to prove. And by reasoning backwards, what I mean is you look at what it is you're trying to prove and say, okay, if I'm supposed to prove two angles congruent, what reasons have I learned so far that would make two angles congruent? And do I see anything that would kind of apply in this particular diagram? And then you just kind of go, this conclusion will be true if such and such is true, which that would be true if something else was true, and so on and so forth. And we'll see a couple examples as we get going here, where reasoning backwards I think might be the way to go. Often you want to look back at previous proofs because a lot of times proofs they're kind of copies of one another. There's a lot of times a different proof that we've done that might help you. So if you're stuck on a homework problem, I guess, you could always look at other proofs that we've done. And also, finally, remember that there's lots of times there's more than one way to do a proof. Somebody else might do a proof slightly differently than the way you did it, but that's okay. It doesn't mean that either one of you did it wrong. All you need to make sure is that your proof is logically sound, it's using the correct postulates and definitions and theorems and properties, and that it's easily understood, that somebody reading through your proof can follow the statements that you're trying to make and understand how your proof works. So let's jump in and take a look at one. This is actually using a new theorem, theorem 2-7, which says that if two angles are supplements of congruent angles or of the same angle, then that means that those two angles have to be congruent to each other. So if two angles are supplementary to the same angle or to two congruent angles, then the two angles have to be congruent to themselves. And so we're going to do that as a proof. We're going to say that angle 1 and angle 2 are supplementary, angle 3 and angle 4 are supplementary, and that angles 2 and angle 4 are congruent. So you can see we have two angles, angles 1 and 3, that are both supplementary to a pair of congruent angles, angles 2 and 4. And we're going to prove that that means they have to be congruent to each other. And you can see here, I'm not providing any statements to start this. We're going to do this whole proof without any statements given to us to start. So let's jump in. Our first statement, let's just go ahead and do a couple of these. Let's look at a couple of the given information statements here, and let's throw those in to start with. Let's say that angle 1 and angle 2 are supplementary, and let's say that angle 3 and angle 4, just forgot my angle sign, angle 4 are supplementary, and we'll give that a given reason. Well, what does that mean? Well, it means that if I add the measure of angle 1 plus the measure of angle 2, I get 180. And if I add the measure of angle 3 plus the measure of angle 4, I get 180. And how do I know that that's true? Because that's what it means if two angles are supplementary. And so we would say that that is by the definition of supplementary angles, right? We knew that these angles add up to 180 because we knew what this word supplementary meant. Now look at this. Look at what I've got so far. And this is what I meant by sometimes you just try going down a path and see where it takes you. I notice that I have two things that both equal 180. And if I go ahead and put those equal to each other, measure of angle 1 plus measure of angle 2 equals, instead of writing 180, I'll say something that 180 is said to be equal to right here, which is measure of angle 3 plus measure of angle 4. I keep doing that. I keep leaving off my angle sign when I write angle 4. Well, I know that this would be true by substitution, right? The substitution property. You could also say the transitive property there because both of this, the angle 1 plus angle 2 and the angle 3 plus angle 4, they're both equal to 180. So you could say transitive property there. I'm going to call it substitution property. But if you look right now, I am pretty close to saying that angle 1 is congruent to angle 3 because I have angle 1 right here on the left side of this equation, and I have angle 3 right here on the right. So if I could just get rid of the angle 2 and the angle 4, I would have a statement that would indicate that angle 1 and angle 3 are congruent. Well, look what we have. We haven't even used this piece of given information here yet. We haven't said that angle 2 is congruent to angle 4, which means that the measure of angle 2 is equal to the measure of angle 4. We've said before that those two statements can kind of, once we say an angle is congruent to another angle, we can in the same statement say that their measures are equal to each other. And that's given information. Why is that important? Because if these two things are equal, then in this equation right here, I can take the angle 2 off of the left and the angle 4 off of the right by the substitution, or not the substitution property, I'm sorry, by the subtraction property, right? So if I subtract off the angle 2 and the angle 4, look what I have. Measure of angle 1 equals measure of angle 3, which is the same thing as saying that angle 1 is congruent to angle 3. And again, I used the subtraction property to do that. And there you have it. I have my proof. And so my strategy there was just start with what I knew to be true, that angles 1 and 2 were supplementary and angles 3 and 4 were supplementary, and then just see where that took me. It took me to a statement that said that they add up to 180. And since the two things both added up to 180, I said that these two statements are equal to each other, 1 plus 2 and 3 plus 4. Then I realized that if I just got rid of the angle 2 and the angle 4, I would have that angle 1 is equal to angle 3, and that's what I'm trying to prove. So there you have it. There's the proof of theorem 2-7, that two angles that are supplementary to the same angle or supplementary to congruent angles, they have to be congruent to each other. Now lastly, we're going to try this proof. And this one says, this is a proof of theorem 2-8, which is similar to 2-7. It says that if two angles are complements of congruent angles, or of the same angle, then the two angles would be congruent to each other. So you can see it's really the same proof, or it's the same statement, the same theorem as we had in 2-7, only changing supplements to complements. So it's the same idea. Let's take a look at this particular proof. First of all, the given information is that AC is perpendicular to BC. So AC right here, perpendicular to BC right there. So let's go ahead and mark this right angle right there, so we don't forget that those two things are perpendicular. We also know that angle 3 and angle 1 are complementary. So how does that prove that angle 3 is congruent to angle 2? Well, let's go ahead and start with this first piece of given information, that AC is perpendicular to BC, and the reason would be given. Well, what does that tell me? Why might that be important? Well, it would tell me that this is a right angle, right? I marked that on my picture already. I know that ACB is a right angle, so let's make that our next statement, that the measure of angle ACB is 90. How do I know that? Because I know what this symbol, what perpendicular means, right? So we can say definition of perpendicular lines. Well, okay, so that equals 90. What else do I know about this picture? Well, I know that if this is a 90-degree angle, that angles 1 and 2 add up to 90. So let's go ahead and state that. I know that the measure of angle 1 plus the measure of angle 2 equals 90. How do I know that to be true? Well, I know the angle addition postulate would tell me that these two angles are going to add up to, and I guess technically what I should say, let me back up a minute. I should say that angle 1 and angle 2 add up to the measure of angle ACB. That's technically what I should be saying right here. And that is by the angle addition postulate. Then I can substitute this 90 for the measure of angle ACB so that the angle 1 plus the angle 2 equals 90. And that is the substitution property. Now, I see that angle 1 plus angle 2 is 90, but also I know that angle 3 and angle 1 are complementary, which would mean they would add up to 90. So this is starting to feel very similar to the last example I did. I'm going to go ahead and state that angle 3 is complementary to angle 1. That is given information. And I know that that means that the measure of angle 3 plus the measure of angle 1 equals 90 by the definition of complementary angles. And now, again, kind of like what we saw in that last proof, we have two things that both equal 90. Let's set them equal to each other. The measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 1. And that is, again, either by substitution or transitive, whichever you'd prefer to use. Now, take a look. I'm supposed to say that 3 is congruent to 2, or that 3 and 2 have the same measure. Well, here I have angle 2 on one side, angle 3 on the other. And look what else is with them. Angle 1 here and angle 1 here again. If I can get rid of the angle 1s on both sides, I would just be left with angle 2 equal angle 3, which is what I'm supposed to prove. And how can I get rid of the 1s on both sides? Well, first of all, I can say that it equals itself by the reflexive property, and then I can use the subtraction property to get rid of it. So I can say that the measure of angle 2 equals the measure of angle 3, which is the same thing as saying that angle 3 is congruent to angle 2. Because their measures are equal, that means that they're congruent. And my reason there would be subtraction property. So there you have it. I proved that one. I kind of just started with what the given information would lead me to until it started to feel familiar. It felt a lot like example 1. And then I kind of finished out the proof in the same way that I finished out example 1. So there are a couple different ways you could actually do this proof. So if you tried this on your own and tried to find a different way of doing it, you might be able to find another way. There's actually a little bit shorter way of doing it. I'll leave that up to you if you want to see if you can figure out the shorter way of doing this proof. This was a bit long. It had 9 steps. But there you have it. There's another proof. So just remember, if you're trying to do a proof from scratch where you have to provide the statements and the reasons, one of the things you can do is just start with the given information and then see where that takes you. And sometimes that would be enough to kind of see some things, and some things would start clicking in your mind that might take you down the road to whatever it is you're supposed to prove. All right, we will see you next time.